For some time, in the 21 years of ACE's existence, the SL14 has been our flagship product, serving the company very well, protecting people and property around the world. However, the world has changed since we developed this product. It's become, sadly, more violent. Civil unrest, mob protests, war, terrorism has demanded that we make a better product. 4 years ago, we answered that demand and we developed the ASLX30. The ASLX30 is far thicker than the SL14. This is our 14 mil product. Obviously, it's a very good product, but very thin. We had to improve that product. Now we're going to look at the ASLX product and the difference between the 14 mil. This one is 54, 55 mil. Rather thicker, almost 4 times thicker than the 14. This product is designed to work on threats that the SL14 cannot meet. Threats, for example, like high-powered bullets, the 7.62 by 25, 7.62 by 51, 5.56. On flat glass, we've had a lot of success. We've been saving lives for the past 3 years around the world. In the theater of war, for example, in Afghanistan, as far away as India, China, Latin America. What about auto glass? In previous videos, we've shown you that we can stop 38 caliber, a 9mm on North American auto glass. But not all auto glass is made the same. For example, in North America, auto glass is 5.2, 5.5mm thick. However, there are some vehicles that the glass is far less. It's anywhere from 2.8 to 3.2mm thick. That's a 1/16 of an inch. We have a cross section cut out here for our benefit. Let's measure how thick the glass is before we test it. So here we have a window that is 3 mil thick. That is a 1/16 of an inch thick. Now let's measure the whole assembly of the glass and the ASLX30. The whole assembly is 9 mil thick. The reason is, using the ASLX30, we have to multi-layer the product. Multi-layering meaning that we have to put one layer on top of another so we get the desired results that we're looking for. In this case, we want to stop a 9mm bullet from penetrating a glass that is a 1/16 of an inch, slightly thicker than a credit card. A 9mm bullet is right here, this, full metal jacket, traveling at 1,200 feet per second, not once but 3 times. Never done before on glass so thin. So this will be a first to be able to do it. On North American glass, on glass that's 5 mil thick, certainly. We do it all the time, we're confident about that, and we promote it as such. But on glass, that's 3 mil thick with our product, has never been done before.
We have a 6 Sauer P226 9mm.
And the bullets we're using are common Remington Luger 9mm 115 grain. The distance we're shooting at would be 12 feet from glass surface to muzzle. So let's do this. Let's measure it out to be sure that we're accurate. Fire one. In fact, the reverse side is still very warm. The polyester side, the SLX30, is still very warm. As we can see, the slug is still right in, embedded into the glass and laminate construction. The delamination is typical, the halo is typical of what we would expect. You can see here on the side that again the glass is 3 mil thick and the laminate is twice as thick as the glass. And then if you come on this side, again, you can see that no penetration whatsoever. What is interesting is the halo on this side seems to extend a little further than typical, looking from the reverse side now. So we're gonna have another bullet placed right in the center and see what happens. So we're gonna take a second shot. Fire 2! Again, as before, we have no penetration. The ball is not in the glass. It did bounce back, so we'll look for it in a second. Small pieces of lead and glass fragmentation came forward. Nothing behind whatsoever. No glass, no laminate. We have absolutely no penetration whatsoever. The halo is smaller than the first one, possibly because it's in the midst of the curve where the bullet hit. The impact was very severe. You could feel it is soft. The glass is fragmented. However, the 9mm did bounce off and hit the floor somewhere. So we're going to take a look at that. But again, no penetration whatsoever. We're going to do one more and see what happens as a result. Trying to do 3 out of 3. Well, this is interesting because here we have the bullet right here caught in glass. In fact, it's still warm. Touch it, LT. This is how the bullet started, and this is how the bullet finished. Very big difference. No penetration whatsoever. The bullet even had sharp edges from being deformed. Yet those sharp edges weren't enough to penetrate through. Again, on the reverse side, it's very smooth, and all we have is a lump. So all 3 out of 3 did not penetrate. We're going to go to extremes now. Lieutenant, give me one right about here. Fire! Well, here we have it. Interesting, Lieutenant. This one, the bullet ricocheted back. This one, the bullet ricocheted back. Yet these two, we captured and enveloped the bullet, the ball itself, the projectile. The delamination on this one is hardly anything. In fact, it's barely noticeable. And the bullet went forward. The curve is right here, whereas this is flat. So I'm sure what happens is, because we're in a curve here, there's more room for the bullet to be captured, whereas flat on, all it's going to do is resist it and kick it back. Again, here we have 4 shots. 1, 2, 3, 4. All shots are equal apart. We have overlapping delamination from all 4 shots and no penetration. Again, this is a window that's 3 mil thick, at a 1/16 of an inch, resisting 4 rounds of a 9mm. Let's put a 5th one. Lieutenant, give me one right here. The 5th shot. Well, let's take a look at that and evaluate that at the end. This is extremely interesting because the first bullet, we have the delamination halo here. The second bullet overlapped and we have a delamination here. Then we have the third one, so they're all overlapping. The 4th one, hardly any delamination. As with the 2 that were on the upper side, we captured the bullet. And again, the same experience is we have the bullet caught inside the window. If you can get close up on this, let's take a look at this. The bullet is right in there, caught between the laminate and the glass. And if you look on this side, again, absolutely no penetration whatsoever. No fragmentation, no slivers, no glass, no lead. Nothing came through from all 5 bullets. 1, 2, 3, 4, 5. What I would like to do now is just get an average of distance between each bullet. This is in inches, 6 inches. 7 inches, 7.5 inches, 7 inches, 7 inches. This is pretty amazing. So the average is about 7 inches, 6.5 to 7 inches between each bullet. We have a halo effect around each one, and yet on such a thin glass with such a high-powered bullet, we're able to resist each one. Lieutenant, give me one more here, and then lastly one more here. Let's push this to the extreme and see what happens. So again, this shot and this shot, shot 6 and shot 7, absolute no penetration. The ball, the projectile went forward, and if you look on the reverse side, over here, absolutely no penetration. In fact, the polyester, the laminate, the PET is smooth, very smooth. It's not even if it's a nick or a tear, nothing. Very, very smooth to the touch. We're going to go one more bullet right here. Lieutenant, in this general area here, one more bullet. And after 7 bullets, after 8 bullets, I think we'll retire this test sample. So here we have the bullet that we're using, a sample of it. This is the outcome of a bullet that hit the glass and bounced off. It's deformed, it's fragmented, it's mushroomed. And let's take a close look at this. Come on in. The before and after. You see that there's nothing left of the bullet at all. Totally fragmented, flattened, and deformed. And definitely did not go in, as you can see on the test sample. Let me be clear. There is no such thing as bulletproof. At no time will advanced coatings ever say something is bulletproof. Yes, the SLX, along with the SL14, is bullet resistant. And it's extremely effective in saving lives, for example, on auto glass, flat glass, retail commercial applications, in the theater of war. It all depends on how far you want to take it. In this case, we were able to resist 8 shots at a distance of 12 feet. Very effective. If this was done where someone took maybe 15 shots or 20 shots, certainly a bullet will go through. That's why we cannot offer bullet proofing. We offer bullet resistance.